Good morning, dear students. In the last video lesson, we have discussed about chemical properties of acids and its uses. Today we'll start with the study of bases. The solutions of substances like caustic soda, lime, and washing soda are bitter in taste and soapy to touch, slippery to touch. These are bases. Bases are those chemical substances which have a bitter taste. All the bases change the color of red litmus to blue. Bases are the chemical opposites of acids. A base is a substance that reacts with an acid to give salt and water only. These reactions are neutralization reactions. Bases can be metal oxides or hydroxides. The family of bases include soluble bases and insoluble bases. Soluble bases are alkali, and insoluble bases include metal oxides and the hydroxides of less reactive metals. Alkalis. An alkali is a base that is soluble in water. A few examples are sodium hydroxide, potassium hydroxide, calcium hydroxide, barium hydroxide, and aqueous ammonia. When we consider these alkalis, sodium hydroxide in water dissociate as sodium ion and hydroxide ion. OH ion is hydroxide or hydroxyl ion. Potassium hydroxide in water dissociate as potassium ion and hydroxide ion. These two hydroxides show basic behavior due to the presence of hydroxide ions only. Magnesium and calcium hydroxide also are bases which dissolve in water to some extent to give hydroxide ion along with corresponding cations. Since complete ionization occurs, hence these bases are strong bases. On the other hand, when we consider aqueous ammonia, ammonia gas in water dissociate partially to form ammonium ion and hydroxide. Only a small fraction of ammonia molecules form hydroxide ion. Most of the molecules remain unchanged. Hence, this is the example of weak alkali or a weak base. For bases, the group 1 hydroxide such as lithium hydroxide, sodium hydroxide, potassium hydroxide are strong bases. Other hydroxides can be considered as weak bases. Ammonia or ammonium hydroxide is the most common weak base. So when we discuss the differences between the two, we can say that a strong base is a compound that can completely dissociate into its cation and hydroxide ion in aqueous solution. Whereas a weak base is a compound which partially dissociates into its hydroxide ion and the cation, creating an equilibrium condition. Strong bases to have dissociation into ions almost 100%, whereas weak ions to have partial dissociation into ions. Strong bases indicated by pH value closer to 14, whereas weak bases indicated by a pH value greater than 7 but less than 14. Strong bases are highly reactive, whereas weak bases are less reactive. Chemical properties of alkali. As these reacts with acid to form salt and water only, the reactions are neutralization reaction and are used to synthesize many salts. The salt depends on the acid used. Sulfuric acid gives sulfate salts, hydrochloric acid gives chloride salt. Thus, if we consider the example of a base which is metal oxide, copper 2 oxide, reacting with sulfuric acid, it will give the salt copper 2 sulfate along with water. The second example is of alkali, where the sodium hydroxide reacts with an acid, hydrochloric acid, to give sodium chloride and water. Second, alkali react with ammonium salts and give off ammonia gas. The general representation is alkali plus ammonium salt gives ammonia, water, and salt. Ammonia has a strong smell and it turns red litmus paper blue, indicating its behavior as basic. Like for example, sodium hydroxide, when reacts with ammonium chloride, gives sodium chloride along with water and release of ammonia gas on heating. This reaction can be used to prepare ammonia gas and as a test for ammonium salt. The pungent smell of ammonia gas is the only way to find out the completion of the reaction. Alkalis can react with the solution of one metal salt to give metal hydroxide and another metal salt. General representation can be an alkali reacts with salt, gives metal hydroxide and salt of another metal. Sodium hydroxide, like for example, reacts with iron 2 sulfate, gives iron 2 hydroxide and along with the salt sodium sulfate. Alkalis are used to produce the insoluble hydroxide precipitates of many metal ions from their soluble salt solution. This is another example where sodium hydroxide reacts with copper sulfate to give salt copper hydroxide and salt as sodium sulfate. This reaction can be used as a simple test to help to identify certain metal ions. Bases react with non-metal oxides to give salt and water. This also shows that metal oxides are acidic in nature and the reactions are neutralization reactions. General representation: non-metal oxide plus base gives salt and water, such as carbon dioxide, which is the oxide of carbon, non-metal. When reacts with sodium hydroxide, the base gives sodium carbonate, the salt, along with water. Second example is calcium hydroxide, which is a hydroxide, a base, when reacts with again non-metal oxide, carbon dioxide, to give calcium carbonate and water. Lime water test for carbon dioxide, which turns lime water milky, shows the formation of calcium carbonate. In the picture we can see bases react to metals to give metal salts and release hydrogen gas. Like for example, ammonium reacts with sodium hydroxide to give sodium aluminate and release hydrogen gas. Uses of alkalis. Ammonia solution is used in window cleaning solutions. Calcium oxide is used to make iron concrete and cement. Magnesium hydroxide is in toothpaste to neutralize acid of teeth, in antacid to relieve indigestion, and sodium hydroxide is used in making soaps and detergents. So we can see that chemical properties of bases include its reaction with metals to give salt and release hydrogen gas, its reaction with acids to form salt and water, which is neutralization reaction, its reaction with non-metallic oxide, which again gives salt and water, which also is the example of neutralization reaction. In the next, we will study about the strength of the acid and bases.